Okay, here is a video solution for problem 3 of exam 2. Alright, we're starting with a transfer function, and the first thing we're asked to do is find the difference equation. Okay, so I'm looking at this product, and I know I can just FOIL that out. And so when I FOIL that out, I get this result for h of z. Okay, so hopefully that's obvious. And from there, by inspection, you can write down the difference equation. Okay, so that's all there is to part A. In part B, you're supposed to use a z-transform approach to determine the step response. Okay, step response means x of n is a unit step. Okay, so what we know is if x of n is a unit step, you can look this up in the z-transform tables. You probably even have it memorized that x of z is this result. Okay, so then using the convolution property, y of z is h of z times x of z. That gives us this, which we then put into a partial fraction expansion. And from here, it's just using the cover-up method to find a, b, and c. All right, what's a little tricky on the cover-up method for part B is, 1 plus 0.7 z to the minus 1 is equal to 0, when z to the minus 1 is minus 1 over 0.7. Okay, so that's what you're going to substitute in on the cover-up method. So I indicated that with a minus 0.7 raised to the minus 1. So you see that everywhere you have the z to the minus 1. Okay, that's what went wrong mostly on the exam when people computed B. All right, so you get this number for A, get this number for the constant C. All right, and I would have counted off on the exam for this. I didn't actually write down the answer, so let me move this. What you need for an answer is that y of n is equal to, we look at the a value, 1.25, 0.5, to the n, plus a 0.9265 minus 0.7 to the n, and then minus 1.765. All this is multiplied by a unit step function. Okay, so that's the final answer for part B. All right, and then in part C, you're asked to find the steady state response. And remember, steady state is much easier to find the total solution. That's part of the point of this problem. Okay, so x of n in this case is supposed to be cosine pi over 3 n. So you just have to identify the x value and the z value that you can use to model that with a complex exponential. Okay, so x should be 1, z is equal to the e to the j pi over 3. We've done this lots of times. So you just plug that number in for z into the transfer function. We know what x is. This is a matter of executing things properly on your calculator, and you get this complex number. I converted this to degrees just because I think it looks nicer. All right, so once you have those two numbers, you have the steady state solution because the pi over 3 part never changes, and you just get the magnitude and the phase. Okay, so there's the solution to problem number 3.